Hey everyone, welcome back to this channel. I am Saurav Agarwal and you are watching Datahat, your one-stop source to upskill in AI. Now, many of you have been recently exploring the RAG pipelines trying to build the Retrieval-Augmented Generation and have faced two major concerns. The first concern revolves around the use of proprietary LLMs such as OpenAI that incurs high cost on you as a developer and has privacy concerns relating to the data. The second reason or the second concern revolves around the different file formats such as CSV, TXT, JSON, DocX, PDF, and others. Many of the solutions out there on the internet handle these different file formats using multiple document loaders, thereby making the pipeline complex and difficult to manage. What if you can build a simple pipeline that leverages one document loader that can deal with multiple file formats by itself identifying the correct parser for the file format? Yes, in this particular video, we are going to build a simplistic yet effective RAG pipeline that leverages open source LLMs such as Llama 2 and can deal with multiple file formats using a single document loader, thereby keeping the pipeline very simple. In four simple steps, we are going to build this simplistic pipeline. So make sure you watch till the end. And if you're new to the channel, make sure to subscribe and hit that bell icon so that you never miss a video. Now let's get started. So this is an RAG pipeline that we have built, and using Gradio, we have created an interface. We have specified the file name using which we want to query our responses. This file basically contains a biography of an anonymized person containing their life history, about their education, about their college days, graduation days, and then again in their PhD days, right? So now when I pass in a query which grad schools I applied to and why, it correctly fetches the response from this document. I'll quickly show you this document in a while. And from this particular document, we see that data has been fetched. I applied to two graduate schools, RISD and Academia de Belli RT in Florence. So whatever that information is, and this information is correct based on the text that we have supplied. Now, let me quickly walk you through the data that we have supplied. This is xyz.txt file which contains the biography of an individual. This data has been anonymized. So it says like before college, the two main things I worked on outside of school were writing. It talks about the mid 1980s. It talks about microcomputer. It talks about the graduation days of this individual and also the PhD days. Okay, so this is a very generic document. You can use any other document of your choice and then work accordingly. Now let us quickly move to the coding section and help you implement this pipeline in four simple steps as we promised. So I have uploaded this xyz.txt to my Google Colab environment. I'll stop my Gradio pipeline and then get started with the simple pipeline. Right. Once we have built a simplistic pipeline, you can very well call the same using Gradio as we have already done in our earlier videos. Okay. So now just to brush upon the things that why do we actually need an REG pipeline is because whenever we talk about LLMs, so most of these LLMs require high computational cost in terms of training and also requires a large amount of time for their training. Therefore, they have a standard cutoff date and their knowledge base is restricted. Now, if you want to leverage these LLMs on your own specific, on your own custom data sets, RAG pipeline is one such effective technique using which you can build or you can leverage these LLMs on your own custom data without incurring any additional cost or without incurring high cost. Okay, there are four specific processes that are involved in this RAG pipeline. And as we talked about these four simple steps, this involves the external knowledge base. Using a document loader, we are going to read through this external knowledge base. Then we are going to process this external knowledge base and perform chunking and vectorization, further storing them in a vector database. The third step involves around the retrieval, fetching the relevant chunks from these chunks that we have generated based on the query that we supply, and finally generating the corresponding output from the document. Okay, so now for these four steps, we have to install certain packages. The first package that we are going to install is the llama-index. In this particular video, we are going to leverage llama-index in order to build the RAG pipeline because it is very lightweight and it provides a very simplistic approach to building an RAG pipeline. From this llama-index, we are going to import simple directory reader and vector store index. Just follow these steps as I'm going through. Okay, now let me just load through the documents. I'm directly passing the name of the file here because we already know you can take this as an input. sorry, it's directory reader and not document reader. Okay, let me show you the document that has been generated. See, the document, the xyz.txt has been read, and various metadata and along with the text, it has been stored here. Another two packages that we need to install are the llama-index LLMs Hugging Face, because as I mentioned, we are going to leverage open source LLM, and the open source LLMs will be considered from Hugging Face. And we are also going to import this embeddings Hugging Face, right? Install these two libraries. I have already installed them. And now once we install these libraries from llama-index.hugging-face, import Hugging Face LLM, we are going to create an LLM pipeline, and we are also going to import this prompt template, because these, the LLMs that we are going to leverage, say for instance llama 2 or Microsoft Phi 3, these are chat based or instruction tuned LLMs, and they require certain prompts. Okay, we are also going to import torch. Now depending if you're using a GPU based environment or a CPU based environment, you can import torch and work accordingly. Now here I'm going to showcase you two examples of LLMs. One is using llama 2, other is using the Phi 3. So for Llama 2 7 billion chat model, we have this repo ID from Hugging Face. You can check this up. This is the Llama 2 7 billion chat Hugging Face. In order to use Llama 2 models or any Llama models, you require a form to fill up, which is as part of the Meta agreement. It does not incur any cost, but you need to fill that up, and it takes around 24 hours in order to be activated. For Phi 3, you do not require any such additional agreements. You only need to have a Hugging Face account, and you can directly leverage it. So this is the repo ID of Phi 3 Mini 4K Instruct model. And as a system prompt, we are specifying that it is an AI assistant that answers questions in a friendly manner. Some of the restrictions that we want to impose, just read through it. It is a very simple prompt. Generate human readable output. Avoid creating output with gibberish text. Generate only the requested output. Don't include any other language before or after the requested output. Never say thank you, that you're happy to help, that you're an AI agent, etc. Just answer the questions directly. Generate professional language typically used in business documents in North America. This can be modified as per your own requirements. Never generate offensive or foul language. Now, for this system prompt, we have to generate a query wrapper depending on the LLM that we are using. And this structure has been provided in the documentation that is available in Hugging Face. So if you open up Hugging Face, let me show you an example. Hugging Face models. So if you open up this documentation herein, I'll show you, right? It specifies the format in which you should pass the input. For example, here is the format that Microsoft Phi 3 4K instruct model expects. Similarly, for Llama 2, there is another format which has been specified accordingly. Okay, so the first one is for the Llama 2 model. The second one is for the Phi 3 model. If you're using any other open source LLM, then you can choose accordingly. Now, in this particular video, we are not going to load this Llama 2 model because it takes a larger time because of its size. We are going to use the Phi 3 model, and it also has similar performance. You are free to use any, right? So for this LLM Phi 3, we are calling this Hugging Face LLM module. We are passing the context window, which is 4096 fixed for Phi 3 because we are using a 4K model. Max new tokens, we are specifying 2048. You can vary this accordingly. We are passing certain parameters relating to temperature, top P, and whether we want to sample the generated outcomes. We are passing the query, or basically the prompt that we have specified above. Next thing, we are specifying the tokenizer name, which is again the name of the model or the repo ID, the model name. We are specifying device map as auto because we want the environment to use a GPU based environment if it is available. And for the model parameters, we want, or the model weights, we want them to be loaded in a float 16 format because of the size constraints, obviously, right? Once our model has been imported or model has been loaded, I'll show you what will happen. It will download the weights from Hugging Face, and it will generate an LLM object here. Okay, with this LLM object, what we need to do is, I'll show you in a while. Now here we are generating an embedding, right? This embedding is used to represent the chunks in a vector format. So for this particular embedding, we are using BAAI BGE small en v1.5. En represents the English language, right? And this has been taken from Hugging Face embeddings again. We are creating an embed model which uses Hugging Face embedding module and passes the model name as embedding model name. Fine. So far, I think the things are very simple. We have just followed one step, which is the document loader. Then we have uh, basically created an LLM object, right? And we have created an embedding model object. Now, within our Llama index settings, we have to specify any specific LLM model that we are using, any specific embedding model that we want to leverage. Otherwise, by default, it uses OpenAI. Okay. So here in the settings, we have specified llama-Phi3 as our LLM, and in the embed model, we have specified our embedding model. The next thing, we need to create a vector index. Okay. Okay. So we have created a vector index. Now our next objective is to create a query engine, right? So after you have created a vector index, this is a part of indexing your chunks. You have to create a query engine that will be used to fetch the relevant responses. Okay. Now my query engine is ready. The final thing that I need to do is generate the response. I'll again go back and brief you through some of these steps and help you understand it once more. But just let us quickly look at the outputs now. I'm taking the user query as input and passing it to the response. I'll print the response here. So it gives us the response that before college you were involved in writing and programming. You wrote short stories that were not very good, and you attempted to program on an IBM 1401 computer. You also built your first computer, a Heathkit, and started programming simple games, a program to predict how high your model. So this is the response that is actually being fetched from the document that we have supplied, xyz.txt. And since the narration is in the first person using I, so therefore it responds everything based on me as a person, me as a pronoun here, right? I is a pronoun here. Okay, so I hope you understand this simplistic pipeline. I'll again brief you the four steps that we talked about. Okay, so the very first step is the document loader, simple directory reader. Now this is the speciality of simple directory reader, that it can read multiple file formats and automatically decide the format parser for each of the file format. Say you can pass a txt file, you can pass a csv file, json file, or a pdf file, and other file formats, and it will automatically determine the parcel. You don't have to worry about different file formats. The first problem has now been resolved. The second, we create an LLM pipeline, or basically we create a prompt and then an LLM for that prompt. This is a completely open source LLM. So our second concern has also been taken care of, that we don't have to use any proprietary LLM and the data remains in house. Now, once we have this LLM, we modify the settings of our Llama index. With these settings, we create a retriever, or we create a query engine. Query engine is nothing but the retriever. We have already processed them using the vector index, vector store index. So it internally chunks the documents and then indexes them. With this query or retriever, we are finally generating our response. It will utilize the LLM in the backend, llama-Phi3 that we have specified, and generate the corresponding responses. If you find this content useful, if you find it simplistic and yet effective enough, I want you all to comment below and let me know your thoughts. And make sure you hit that thumbs up so that it reaches to more and more people who can make best use of it. See you in the next lecture. Have a nice day. Bye bye. Jai Hind.